objective 6. We want to solve linear inequalities with 3 parts. We have that an inequality that states one number is between two other numbers is a 3-part inequality. Something like -3 is less than 5 is less than 7 states that 5 is between -3 and 7. A word of caution. So 3-part inequalities are written so that the symbols point in the same direction and both point towards the lesser number. So you cannot and do not write 8 is less than x plus 2, which is less than 3, because this implies that 8 is less than 3, which is not true. So that would be false, so we can't write it in that way. We have to write them in the same direction, pointing towards the lesser number. And the form we want our final answer in is we want final answers in the form of something like a is less than x, which is less than b, or a is less than or equal to x, which is less than or equal to b, or a is greater than x, which is greater than b, a is greater than or equal to x, which is greater than or equal to b, or any mixture of in between. So we can say any mixture, any other mixture. So we want our final answer to look like this when dealing with 3-part inequalities. But what really happens is that we want to solve for the variable in a 3-part inequality the same way we would solve for a regular 2-part inequality. So example 3. We want to solve the 3-part inequality and plot the solution on a number line. Just like in our last section, we're actually going to detail 2 separate methods in order to do this. So I'm going to go with method 1 and method 2. So for method 1, we're just going to go about this problem like how we would any 2-part inequality. So we have 4 is less than 3x minus 5, which is less than 10. So what we want is something like a is less than x, which is less than b. So this is a kind of deal that we want to have. Now, we want to get rid of our minus 5 from the center. So we can add 5 to all of our sides of inequalities. This means that we're going to take 4 plus 5 less than 3x minus 5 plus 5 is less than 10 plus 5. And this is our addition property of inequality. And we're going to have to move method 2 over a bit. And now we can simplify. So 4 plus 5 is 9, which we now say is less than 3x, because we got rid of our 5, which is less than 15. But we still have a coefficient in front of x. We still have 3 times x, where we just want x. So we're going to divide each term by 3. Which this is the multiplication property of inequality. So we're doing the same thing as we would normally do with a 2-part inequality. It's just that now we have 3. So when we divide by 3, 9 divided by 3 is 3, less than x, less than 5. So now we have our range here. And we're just going to put this in interval notation instead of set builder notation now. And what we see here is that 3 and 5 are not included because we don't have the equal to. So we're going to give round parentheses with our lower number 3, comma, higher number 5, again with our rounded parentheses since 5 is not included. So this is our answer. Once we're done with our second method, we will go ahead and graph it on a number line. But now with method 2. So another way that you could do this is when you have something like 4 is less than 3x minus 5, which is less than 10, and we still want a final answer that looks like a is less than x, which is less than b. What we can do is we can separate our 3-part inequality into 2 2-part inequalities. And now we can have 2 where now we have, and let's write them in different colors to kind of identify that we've separated them. So 4 is less than 3x minus 5, and we just stop it there. We take the 2 terms or 2 expressions to our right, and now we're going to take the 2 expressions to the left. We'll use our light green here. And now we have 3x minus 5 is less than 10. So we've separated into 2 separate equations. And now we can solve like how we would normally solve. So we have 4 is less than 3x minus 5. We want to add 5 to both sides. So we're going to say 4 plus 5 is less than 3x minus 5 plus 5. 4 plus 5 is 9, less than 3x, which then we divide by 3. And we get that 3 is less than x. Now for our other inequality, we'll do the same thing. So we have 3x minus 5. We want to get rid of our 5, so we'll add 5 to both sides, which gives us less than 10 plus 5. So we get 3x is less than 15. We divide by 3 on both sides, and we get that x is less than 5. Since we have that x is obviously equal to x, we can combine our inequalities keeping their direction the same. So now, since we have x is equal to x, we can even rewrite this as 3 is less than x, which is equal to x less than 5, and we simplify this into 3 less than x, which is less than 5. And this gives us the same interval notation from 3 to 5. We have the same answer as we have from our other method. So 2 separate methods. You can choose whichever one feels easier to you when you want to solve these problems. One definitely looks a little shorter, but one may make more sense. So you can choose whichever method you would like when you want to solve these inequalities. You should get the same answer. That's the key there. Should get the same answer. Since we found our interval, we can go ahead and we can plot our interval on our number line here. So starting with our lowest value, let's just make our lowest value 0. We have a very long number line here, so let's skip some numbers. 0, 1, 2, 3, 4, and 5. And since we are not including 3 and 5, they get rounded parentheses. So we want to give our rounded parenthesis here at 3 and another round parenthesis at 5. So we have our rounded parentheses. And we see here that they are containing the values in between. which we can now highlight. So we're saying all the real numbers between 3 and 5, not including 3 and 5, are all valid solutions. And some final words here. Be especially careful of whether to use parentheses or square brackets when writing and graphing solution sets of 3-part inequalities. The following table illustrates the 4 possibilities that may occur. So we do see some different kind of sets here with our different set builder notation and our intervals. We kind of see the mixture of strictly less than or greater than, and less than or equal to, or greater than or equal to. So in the case where we have something like x, which is a, which is less than x, which is less than b, in our interval notation, we put a comma b in rounded parentheses. And then on our graph, we also include rounded parentheses and all the values in between. Then if we have something like a is less than x, which is less than or equal to b, we're going to have our interval from a to b, where a gets a rounded parentheses since it is not included, but b gets a square bracket because it is included. And we see this reflected in our graph. Then if we have a is less than or equal to x, which is less than b, we now want to give that square bracket to a since a is included, but b is going to have a parentheses since b is not included. And we see this reflected in our graph as well. Then lastly, if we have a is less than or equal to x, which is less than or equal to b, then we have the interval from a to b with our square bracket. So we're including a and b, and once again, we see this reflected in our graph. So it is important to understand the difference and remember the difference when graphing them. And know that you can have a mixture. You're not always going to have with both parentheses or both square brackets. You can also mix them together. So that concludes section 2.4, and I will see you again in our next section.